some more. I taught it as a shortcut to do some limits a little more efficiently. But there are some little kinks and things you got to think about with L'Hopital's rule as you get into problems that are supposed to be worked with L'Hopital's rule. So we've got to just delve a little deeper. So today's not going to feel like anything new, really, except that we've got to look a little deeper into L'Hopital's rule. The bell ringer is the L'Hopital's rule you already know how to do, we hope. So the first one, first of all, what do you do with any limit no matter what it is very first? Plug it in. Don't forget that step because if it's not 0 over 0 or infinity over infinity, you cannot use L'Hopital's rule. If I plug in -1, I do get 0 over 0, so that lets me know I can use L'Hopital's rule or I can use factoring. Both work great. There is a little section on your homework. I can't remember if it's tonight or tomorrow night, but it says find the limits using methods from chapter 1 and then find the limits using L'Hopital's rule. Well, chapter 1 would just mean without L'Hopital's rule. So the first way you learn limits before you do L'Hopital's rule. So L'Hopital's rule, I take the derivative of the top, the derivative of the bottom, then plug in -1. Go with me that there. Plug in -4. This one, if it were me, I would not use L'Hopital's rule to do this limit. But you can if you want. Why would I probably not do it? The answer is 3 over 2, and I can see that without doing any work. So I probably wouldn't use L'Hopital's rule. But if you did come to one you didn't know how to do, it is infinity over infinity. So I could do L'Hopital's rule as many times as I needed to get down to 3 over 2. I actually would need 2 applications of L'Hopital's rule, although it sounds like we can figure it out right. So, 3 over 2. Any questions about that one? The last one, what is the method you would have had to do before you learned L'Hopital's rule? Multiply by conjugates. I would have needed to multiply the square root of x plus 2 minus 3 times the square root of x plus 3 on top and bottom. It's lengthy process. It works great. I'm going to work it with L'Hopital's rule since that's the lesson of the day, but both work great. I don't know which one's faster. L'Hopital's rule takes a while because you have kind of a yucky derivative. Conjugates takes a little bit of work because it's multiplying by conjugate. So, it just depends on which one you're faster at, on which one's better for this type of limit. Whichever one you think is better, I agree. 1/2 x plus 2 to the -1/2. Make sure you pay attention to the chain rule. This one is times 1, so I don't need to do any work. 5 that one. Something I did in my head that we need to do really quick before we start doing any of this. What should we do first? Plane 7. Because why? If it's not 0 over 0, I'm done. Either the answer is the answer I got, or the answer is does not exist because we have a class on those. So, now plug in 7. 7 plus 2 is 9. 9 to the -1/2 power is 1/3. So 1/2 times 1/3, which is 6. So that's a little bit of revisiting the L'Hopital's rule that you know. Today we're just going to do some nasty problems. You probably don't have to write this down. It is L'Hopital's rule. And what L'Hopital's rule says is if you have a limit as x approaches a of f of x divided by g of x, and that limit results in one of the 2 following indeterminate forms, 0 over 0 or infinity over infinity, then you can do the limit of the derivative of those 2 pieces, and those are equivalent. They are only equivalent if they were 0 over 0 or infinity over infinity. If you read the proof in the book on where L'Hopital's rule comes from, you can see the use of the 0 over 0 or the infinity over infinity. It has to be that way or this doesn't work. So anyway, that is L'Hopital's rule. It is the same L'Hopital's rule I put on the board last February or March or whenever we learned L'Hopital's rule. on for the most part today is, what if it's not in one of those two forms? Is there anything we can do about it? Is there any way we can make L'Hopital work for us? That's kind of where the focus is going to be today. So sometimes the problem isn't 0 over 0 or infinity over infinity. And we need to make it that way before we can work the problem. So there are other types of indeterminate forms, and L'Hopital's rule does not work on those. Here is an example. If I plug in infinity, I would get 0 times infinity. Does everyone agree that's what this one is? It's a 0 times infinity. That is also an indeterminate form. I do not know the limit with 0 times infinity. However, I can change it into something that is L'Hopital rule ready. Any ideas on how I could use some algebra to change the first one to where I could use L'Hopital's rule? Move the e to the bottom. Okay, move the e to the bottom. Why can you do that? So the limit is x approaches infinity of the square root of x over e. I'm going to do the limit as x approaches infinity. Now, some of you already know the answer because you know that e to the x grows faster than the square root of x. So there are, even though we had to rearrange either way, whether we use L'Hopital's or not, I'm not discounting other methods you have, and you don't always have to use L'Hopital's rule. However, either way, a rewrite in this format is probably a necessity so that you can see that process. But I can now do L'Hopital's rule. And that negative 1/2 actually moves the square root to the bottom. So now they're both on the bottom, right? So as x approaches infinity, what happens if both of the pieces are on the bottom? Both are close. That limit is 0. Again, you probably knew that up at the top of that problem. That's okay. The next one. As always with a limit, what do I do very first? Plug it in. So if I plug in 1, what's the natural log of 1? 0. So that piece would kind of go to infinity minus infinity, which is another indeterminate form. I don't know what that means. Okay. So in the current setup, I don't know the limit, and I can't use L'Hopital's rule because it's not 0 over 0 or infinity over infinity. Any ideas? I want it to be in that format. I'll let you think for a minute. Okay, what's the word for that? Common denominators, yes. So I think that's a great plan. If I get a common denominator, it changes this into a fraction, which means I have a chance at it being a L'Hopital's rule problem. So I'm going to do that. So I'm going to do x minus 1 minus the natural log of x over the natural log of x times x. Now I'm going to try plugging in 1 again. And this time, do you agree that I get 0 over 0? Now I can use L'Hopital's rule. So kind of the new thing for today is sometimes they are not in the correct indeterminate form to use L'Hopital's rule, and so we've got to use some algebra to get them there. So that's the new information. So I get the limit as x approaches 1 to the right. The derivative at the top is 1 minus 1 over x. Does everyone agree? questions about that? What do I have to do on the bottom? Product rule, left to right, left to good. So left, T right, plus right, T left. Now what? Extrapolating in 1. I still get 0 over 0. And I could try to maybe do a derivative right now, but I would do algebraic simplification first. Maybe something will cancel. So I'm going to do some algebra first, then I will do a derivative if necessary. On the top, I can get a common denominator. And I get x minus 1 all over x. On the bottom, I can also get a common denominator. And I get natural log of x plus x minus 1 all over x. So everybody agree with that? Split and multiply. Multiply by the reciprocal of that denominator. What's kind of nice about that? Slightly nice about that. The x's cancel. Even if I have not successfully turned this into something I can find a limit of yet, have I simplified it for a repeated application of L'Hopital's rule? That'll be a much easier second L'Hopital's rule if necessary. So let's find out. Do I still have 0 over 0? Yeah. Oh, I should have. Yep, I did need a comment on it. Thank you. Did everyone hear his question? You're right. Okay, any. Still 0 over 0. So what do I do next? Do the derivative of the top and the bottom. So you're getting to see the worst of the worst L'Hopital's, right? 1 over, I have to do a product rule on this x, natural log of x. Everyone agree? What's x times 1 over x? 1. So 1 plus 1 is 2. And what is the natural log of 1? 0. So this limit is eventually a half. Any questions about that one? Horrible, nasty. Really quick, can you check limits on your homework like you can check integrals? F2 something?
I don't know. I even negative x.
You cannot use L'Hopital's if it's not 0 over 0. Like it does not work.
Okay.
F33 is the limit, and you do comma x, comma what you're approaching. So you can check these limits in your calculator. Of course, I want to see work. This is the last one. They're pretty nasty ones, but this is the last one. Okay, let's look at one more. Which I should have done. I should have done the one with the 1 above the x. Then you get E, which
whole lot of C, but
Okay, so try plugging in infinity. It's weird, right?
All the
Yeah, I don't know what it is, right?
go ahead.
So, I don't know what it is. No, you cannot distribute it. It's not one. It's not.
Why wouldn't it be? I just want to know.
Because you can't, it's just indeterminate. You don't know what one plus something to the infinity power is.
Well, it's 1 plus 0.
A minuscule piece, yes. Unfortunately, it's an indeterminate form. I just don't know. So we need to find out, which is going to take some work. So the first thing we're going to do anytime we have infinity as a power, we can't work with L'Hopital's rule with an exponent, so I need to get rid of that exponent. The only way I know to move an exponent out of an exponent is in logarithms. Is everyone agree? So, side note, I'm going to call f of x 1 plus 2 over x to the x power. Side note, 1 plus 2 over x to the x power is f of x. I'm going to take the natural log of both sides of that, and I'm going to find that limit. I then will have to kind of go back and see what that means f of x would be. So this is the worst of the worst. You have a power. So what I'm going to do is I'm going to take the natural log of both sides. The problem in your textbook is slightly different than this one, but for this, I think you could use any logarithm, but our goal is eventually to use L'Hopital's rule, which one's the easiest for derivatives. But you could use any logarithm. Natural log turns out to be the easiest. That is a good question. And there is no great answer. Okay, so now this is my piece I'm now going to work with, and I'm going to look at the limit as x approaches infinity of that piece, which is x, natural log of 1 plus 2 over x. Why in the world is that x in front? Where did that come from? The property of logarithms where I can move a power down. In fact, that is the whole reason I chose properties of logarithms. Unfortunately, we now have an infinity times 0. So we haven't gotten any better yet as far as logarithms go. I've got to make a fraction out of this thing to make it work. Well, remember the trick we played with e to the x where we moved it to the bottom? Even though x is to the power of 1, could I move it to the bottom if I wanted to? What would I make it if I moved it to the bottom? X to the negative 1 power. Is that algebraically legal? So I'm going to call this natural log of x, natural log of 1 plus 2 over x, divided by 1 over x. Or x to the negative 1, either way. Actually, x to the negative 1 might be better because it's derivative. I do now have 0 over 0. Does everyone agree? It's a good one?
Yeah.
Okay, wait right there. I'll check it. Check that line. Because we can't. And why am I even wanting to do that? So I can use L'Hopital's rule. Remember, to use L'Hopital's rule, I have to have a fraction 0 over 0 or infinity. So now I can use the derivative at the top, and this answers Kaylee's question on it. I think natural log is not a different log. What's the derivative? And it's not a pretty derivative, but in this one I can find. What's the derivative of natural log of 1 plus 2 over x? And 1 over 1 plus 2 over x times the derivative of 1 plus 2 over x, or you could have that on the top either way. What is the derivative of 1 plus 2 over x? Say out loud, Brandon.
Negative 2x.
Why is it negative 2x? Y'all are trying to do integral. And by the way, if you're doing integrals on that, it would be natural log, not. Okay, any questions about that so far? Over the derivative of 1 over x, which you can do that pretty fast now that you just did 2 over x. So it's negative 1x to the negative 2. Not the derivative. Okay, let's do lots of simplification. So you move the negative 2 of it. You wouldn't have, actually, the rest, I'm going to leave it over there. So I'll lose the setting. So on the top, the first thing I did is just a rewrite of the negative 2x to the negative 2. I can do some distributing to simplify that. So I get the limit as x approaches infinity of negative 2 over x squared plus 2x. Distribute the x squared. Hey, times x squared over negative 1. Everyone agree? Any questions about that so far? At this point, you probably all could figure out the answer, even without repeated applications of L'Hopital's rule. Because it's, you look at highest power, everyone know what I'm talking about at this point. There's no logarithms, no over x's. Much nicer. Simplifying the top so that you can do this without doing simplification. And technically, if we are using L'Hopital's to its fullest potential, we would continue to take derivatives until we had no x's in it. But however, this is approaching infinity. Do we agree that limit is 2? But we're not done. Yeah, what is this the limit of? This is the limit of the natural log of f of x, correct? So, the limit as x approaches infinity of the natural log of f of x equals 2. E to the 2. I agree. Why e to the 2? Undo the element, go backwards, back to where we were originally, right? So to undo that natural log, I would get the limit as x approaches infinity of f of x is e. Check your calculator. What's it say?
Why is it that?
It's very interesting that it comes out to that number. In fact, that particular formula. That's why I said I kind of wish it was a 1, but that's the one your textbook did, and I always like to do it. I want to say you have, so you can still look at your textbook. If this is a 1, that is the compound interest formula. You know the compound interest formula where you're compounding like n times a year, compounding interest. And so as x approaches infinity, what you get is a compounded continuously formula. Because the x was how many compounding periods you have. And so that's where the PERT formula comes from. So this is actually essentially the proof of where the PERT formula comes from. But the reason it's T is because you're compounding continuously. Weird. Craziness.
So on your calculator, how do you
Do the limit. Lim, type of function, comma x, comma infinity. Whatever your approach. F3. Okay, I'm handing out a L'Hopital worksheet due Thursday, and then L'Hopital plus improper integrals due Friday. You can see why L'Hopital is taught close to improper integrals. Could you, on an improper integral problem, end up needing L'Hopital's rule? So you can see that could kind of collide. So I'm going to have 2 worksheets out. Thursday and Friday are the due dates.